In this video, we're going to be talking about velocity and flow diagrams. So I have the sample project opened up, and this is the hydronic riser diagram that we're going to start with first. As you can see, there's GPMs throughout the entire system, all the way back to the pumps and even into the boiler. So now these GPMs can be used in Revit with Pipe Sizer to size the pipes based upon a velocity or pressure drop. Otherwise, these GPMs can be used by the designer with third-party tools for sizing pipe. So before we get to this riser diagram, we need to make sure that that everything is connected, that there's not some VAV boxes downstream that aren't adding any flow, or there's some unconnected elbows, because then the pipe sizing is entirely invalid. So before I get to this riser diagram, some people like to turn on disconnects in all of their piping, and they can fix connections that way. Another method is also to use some of the analysis views set up in our model. So if you go to analysis, floor plans, let's start with hydronic, and let's start with the flow diagram. This diagram has a color legend applied to it, and as you can see, it's already set up for all levels of the building, and essentially it's just flagging any pipe with zero flow conditions. So if we had any type of disconnect, so if this pipe wasn't fully connected to the VAV box, we would see that right away in this diagram. We're like, oh, okay, we got to connect that to the VAV box. You know, you could also see that with a disconnect. But even if you have everything connected, if your VAV box has 0 GPM, that's still this method would still indicate an error before you size your pipe. Now the other method that you can use, or views, to help you design your system is friction or velocity diagrams. I'm going to go to the velocity diagram, and as you can see, we have a color legend applied here as well. So say, for example, your firm didn't want any pipe sized over 4.5 feet per second in hydronic systems. If that was the case, you could use this view to pinpoint any sections of pipe that don't meet that tolerance. So like here's some runouts to a VAV box. Let's update those. So again, it's just another design tool to help you make sure you have the valid GPMs in your piping system before you go to size it. So with Revit, you also have to be aware that it is showing peak connected flow. So if you're sizing your pumping system off of a block load where your pumps do not equal the peak, well, then your designers need to be aware of that. So in this case, even though this pipe is indicating that we have 44.5 GPM, if the pump is sized for a block flow below this, then you don't need to upsize this pipe. So you're sizing it just based upon your block flow. So it'd be nice if Revit or Autodesk in time adds a design flow to a piping system or a block flow, and so you can see that in addition to total connected flow. Now on the domestic side, we can do the same thing. So before we get to the plumbing riser diagrams, so here's some completed waste and vent riser diagrams. Before we can use these fixture units and trust that they're right for sizing the piping system, we need to know if there's any disconnects or if there's any sections of pipe with zero flow. So once again, going to analysis under plumbing, we can do the same thing with flow. So now this particular color legend is flagging any piping that is below 0.25 fixture units or more. So I came up with 0.25 because that was the minimum number I saw for, I think, an electric water cooler in the plumbing code. So now in this case, you'll be able to see in any of your pipes if you don't have flow. So once again, these are just the tools that go hand in hand with sizing piping systems, before you size it in Revit and before you can trust the fixture units, you want to look at these diagrams to make sure that you have the correct amount of fixture units or GPM in your system.